Hello everyone, welcome back to the channel. In today's video, we're going to dive into context managers in Python, an essential concept often asked in technical interviews. Context managers help you manage resources efficiently, ensuring that they're properly acquired and released, like when handling files or managing database connections. We'll explore how to create your own context manager using the we statement and see practical examples to help you prepare for interviews. Let's get started. The definition. Context managers in Python are incredibly useful when it comes to managing resources like files, database connections, or any other system resource that requires proper setup and cleanup. The beauty of using a context manager is that it automatically handles the setup when you enter a block of code and ensures everything is properly cleaned up. Even if an error occurs, you've probably already seen it in action with the with statement, especially when working with files. For example, when you open a file using with open, Python takes care of closing the file for you no matter what happens inside that block. A context manager works by implementing two special methods underscore underscore enter and underscore underscore exit. The underscore underscore enter method handles everything you need when you start the block, while underscore underscore exit takes care of cleanup when you're done. So even if an exception is thrown inside the with block, underscore underscore exit makes sure the resources are properly released. If you want an easier way to write context managers, Python also provides the context module which allows you to create them using decorative. It's a neat tool that comes in handy for managing resources efficiently. Now that we've covered the basics of how context managers work and why they're so useful, let's dive into some practical examples. You'll see how easily you can manage resources like files or database connections and how Python ensures everything is handled properly, even if something goes wrong inside the with block. So let's jump into the code and see it in action. 1. Basic file handling with statement. Question: write Python code to open a file, write some content to it, and ensure the file is closed properly using a context manager. In this example, we are using Python's with statement to handle file operations in a clean and efficient way. The with statement simplifies resource management such as opening and closing files. When you use with open example.txt to as file, it opens the file example.txt in write mode v2. If the file does not exist, it is created. If it exists, the content is erased, allowing you to write new data. Inside the with block, we use the file.write method to write the string. This is a line of text into the file. The key advantage of using the with statement is that it automatically handles the closing of the file once the block is exited. Whether the block finishes successfully or an exception occurs, Python ensures that the file is properly closed after the block. This eliminates the need to manually close the file using file.close, reducing the risk of leaving files open unintentionally, which can lead to resource leaks or file corruption. This approach is more concise, reliable, and considered best practice in Python, as it ensures that resources like file handlers are managed safely and efficiently without requiring explicit cleanup. 2. Custom context manager using enter and exit. Question: write a custom context manager that opens a file, writes data, and ensures the file is closed properly even if an exception occurs. In this example, we create a custom context manager using the file manager class to handle file operations efficiently and safely. The file manager class allows us to open and close files using the with statement, ensuring that resources are managed properly even if an exception occurs within the block. The class implements two special methods underscore underscore enter and underscore underscore exit, which are key components of the context management protocol in Python. When the with back is entered, the underscore underscore enter method is triggered. In this method, the file specified by the file name and mode parameters is opened and the file object is returned to the with block, where operations like writing or reading can be performed. Once the with block is exited, either by completing the block normally or encountering an exception, the underscore underscore exit method is automatically called. The underscore underscore exit method ensures that the file is closed, regardless of whether the block was completed successfully or if an error occurred. If an exception happens inside the block, the method captures it and prints an error message. Additionally, by returning true, the underscore 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 exit method suppresses the exception, meaning the program won't crash or propagate the error outside the block. This makes the custom context manager both robust and user friendly, as it automatically handles the necessary cleanup closing the file and gracefully manages any errors. Using this custom context manager with the with statement simplifies file handling and reduces the risk of leaving files open accidentally, which can lead to resource leaks or file corruption. It ensures that the file is always closed properly after use, providing a safer and more reliable way to manage files in Python. 3. Context manager using ContextLib. Question: use the ContextLib module to create a context manager that opens and closes a file. In this example, we are using the context manager decorator from Python's ContextLib module to create a simple and efficient context manager for file handling. Normally, to create a context manager, you would need to define a class with underscore 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 enter and underscore underscore exit methods, but with that context manager, we can simplify this process by using a generator function with yield. The open underscore file function is designed to open a file in a specified mode like W for write or R for read. Inside the function, the file equal to open file name mode statement opens the file. Then the yield statement temporarily returns the file object to the with block where file operations such as writing or reading can be performed. Once the with block is completed, control is handed back to the function. The finally block ensures that the file is properly closed after the with block finishes, regardless of whether the block was exited normally or due to an exception. This is a critical feature of context managers as it ensures that the file is always closed properly, which prevents issues like file corruption or leaving resources open unnecessarily. By using the add context manager decorator and with statement, this code simplifies the file handling process. It abstracts away the need to manually open and close the file, making the code cleaner, safer, and easier to manage. This pattern provides both flexibility and robustness, ensuring that resources like files are handled efficiently and with minimal risk of error. 4. Context manager for database connection. Question: write a context manager that opens and closes a database connection. In this example, we implement a custom context manager using the database connection class to simulate handling a database connection. The context manager is responsible for opening the database connection when the with block begins and ensuring the connection is closed when the block is exited, even if an exception occurs. This is achieved by defining two key methods underscore underscore enter and underscore 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 exit, which are part of Python's context manager protocol. When the with statement is executed, the underscore underscore enter method is called first. In this method, the database connection is simulated by printing a message that indicates the connection is being opened. The method then returns a mock connection string self.connection, which represents a connection to the database. This connection object is made available inside the with block where it can be used to simulate performing database operations. After the with block completes, whether normally or due to an exception, the underscore underscore exit method is called. This method simulates closing the database connection by printing a message. Additionally, the underscore underscore exit method returns true, which suppresses any exceptions that might occur inside the block and ensuring the program does not crash. This is particularly useful for making sure that the database connection is closed cleanly, even in the event of errors. The use of a context manager for managing the database connection simplifies resource management by automating the process of opening and closing the connection. This ensures that resources like database connections are properly handled without the need for manual intervention. It is a robust and clean way to handle resources, reducing the risk of leaving connections open and leading to potential resource leaks. This pattern is especially important in applications that require efficient and reliable resource management, such as database interactions. 5. Locking resources using context manager. Question: write a context manager to acquire and release a threading lock. In this example, we use a custom context manager lock manager to handle threading locks in Python. Threading locks are essential for synchronizing access to shared resources in multi-threaded applications. The lock manager class simplifies this by ensuring that the lock is acquired when a block of code is entered and automatically released when the block is exited. Even if an exception occurs, this ensures that shared resources are properly protected from concurrent access by multiple threads. The underscore enter method is called when the with block is entered, and it acquires the lock using self.lock.acquire. This guarantees that only one thread can execute the code inside the with block at a time, preventing race conditions. Once the code in the block has finished executing, the underscore underscore exit method is triggered, releasing the lock by calling self.block.release. This automatic lock release mechanism ensures that the lock is always freed even if the code inside the block raises an exception, making the code more reliable and error proof. By using a context manager for thread synchronization, we avoid the need for manually managing locks, which can be prone to mistakes, such as forgetting to release the lock or releasing it too early. The lock manager class encapsulates the lock management logic, providing a cleaner and more maintainable solution for handling critical sections in a multi-threaded environment. This approach simplifies the task of ensuring that only one thread can access shared resources at a time, reducing the risk of bugs and improving the overall safety of concurrent code execution. 6. Timing code execution with Context Manager. Question: write a context manager that measures the time taken to execute a block of code. In this example, the timer class is used as a custom context manager measure the execution time of a block of code. The goal is to automatically track how long it takes to run specific operations inside a with block without having to manually handle timing calculations. The underscore underscore enter and underscore underscore exit methods define the context management behavior for the class. When the with timer st block is entered, the underscore underscore enter method is called, which records the current time using time.time and stores it in self.start underscore time. This marks the start of the time block. Inside the with block, any operation such as summing a list of numbers will be executed. Once the block completes, the underscore underscore exit method is called, which records the end time using time.time again and calculates the time difference between self.end underscore time and self.start underscore time. This difference represents the time taken for the block to execute, and it is printed in seconds with high precision. The timer class simplifies the process of measuring code performance. Instead of manually placing time calls around a block of code, this context manager encapsulates the timing functionality, ensuring that the time measurement is accurate and handled consistently. It can be used for timing different parts of a program, making it particularly useful for performance optimization or benchmarking. The context manager guarantees that the start and end times are properly recorded even if an exception occurs, and it provides a clean and readable way to track the duration of code execution. 7. Suppressing exceptions using context manager. Question: write a context manager that suppresses specific exceptions, e.g., zero division error. In this example, the suppress zero division error class is designed as a custom context manager to handle and suppress zero division error exceptions. When a zero division error occurs, such as when attempting to divide a number by zero, the context manager prevents the program from crashing and allows it to continue execution gracefully. This is achieved by defining two key methods, underscore underscore enter and underscore underscore exit, which are part of the context management protocol in Python. When the with block begins, the underscore underscore enter method is called. In this case, it doesn't need to perform any specific setup, so it simply returns the context manager instance self. The core logic occurs in the underscore underscore exit method, which is automatically invoked when the block exits, either normally or due to an exception. The underscore underscore exit method checks whether the exception type is zero division error by evaluating the underscore type argument. If the exception is indeed zero division error, the method returns true, which suppresses the exception, preventing it from propagating and stopping the program. This allows the program to continue executing the code that follows the with block, as indicated by the printed message zero division error suppressed, continuing execution. This approach is especially useful in cases where division by zero might occur but is not critical enough to halt the entire program. By suppressing the error, the context manager enables the program to recover from the error without crashing. Additionally, this method can be easily extended or modified to handle other exceptions, making it a versatile tool for managing specific exceptions in a controlled manner. Overall, the Super Zero Division and Context Managed Manager provides a clean, reusable way to handle exceptions in Python, ensuring that specific errors are gracefully handled without interrupting the program's flow. 8. Temporary Directory Context Manager. Question: write a context manager that creates a temporary directory and deletes it after the block of code is executed. In this example, the temporary directory class is used as a custom context manager to create and manage a temporary directory. The goal is to automatically handle the creation of a directory when the with block is entered and ensure that the directory along with any of its contents is deleted after the block is exited. This is particularly useful when working with temporary files or directories that are only needed for a short period during program execution and should be cleaned up afterward. The underscore underscore enter method is called when the with block is initiated. Inside this method, a directory named temp underscore dir is created using os.makerdires. This ensures that the directory is available for any operation such as file creation or modification during the execution of the block. The path to the temporary directory is returned so that it can be accessed and used inside the block. Once the with block is completed, the underscore underscore exit method is automatically invoked. In this method, shuttle.tree is used to remove the temporary directory and all of its contents, ensuring that no residual files or directories are left behind. This cleanup process occurs regardless of whether the block exists normally or due to an exception, making the context manager robust and reliable. By using this context manager, developers can simplify the process of managing temporary directories, ensuring that they are both created and deleted in a controlled and automatic manner. This eliminates the need for manual cleanup, reduces the risk of leaving behind unnecessary files or directories, and enhances the overall safety and efficiency of resource management in the program. 9. Network connection management. Question: write a context manager that simulates opening and closing a network connection. In this example, the network connection class serves as a custom context manager designed to manage the lifecycle of a network connection. The purpose of this class is to automatically handle the process of opening a connection when entering a with block and ensuring that the connection is properly closed when exiting the block, regardless of whether an exception occurs. This pattern simplifies resource management by encapsulating the logic for setting up and tearing down the connection, making the code cleaner and reducing the risk of resource leaks. The underscore underscore enter method is called at the start of the with block. In this method, the network connection is simulated by printing a message and assigning a mock connection string network connection open to self.connection. This connection object is returned so that it can be used inside the block to perform operations such as sending or receiving data. Once the operations are completed and the block ends, the underscore underscore exit method is triggered. The underscore underscore exit method ensures that the network connection is closed properly by printing a message indicating that the connection is being closed. Additionally, the method returns true, which suppresses any exceptions that may have occurred during the execution of the with block. This means that if an error occurs while using the connection, the program won't crash and the connection will still be closed safely. By using a context manager, this approach guarantees that the network connection is always cleaned up after use, even if something goes wrong. It simplifies the logic needed to manage the connection lifecycle, avoids manual connection handling, and ensures that resources are properly released. This method of resource management is especially important in real-world applications where resources like network connections, files, or database connections need to be managed efficiently and safely to prevent resource exhaustion or unexpected behavior. And that wraps up our deep dive into context managers in Python. By now, you should have a clear understanding of how they work and how to implement them in real world scenarios. Mastering context managers is a great skill to have for interviews as it demonstrates your ability to manage resources effectively in Python. If you found this video helpful, don't forget to like, share, and subscribe for more Python tutorials and interview tips. Thanks for watching, and I'll see you in the next one.